class we are discussing about the limitations to the Bohr's model. So now we are discussing about the modifications in the Bohr's model. So that modification is done by the Sommerfeld. So that's what it is called as the Bohr's Sommerfeld model of the atom. So here, who is the scientist? Scientist is the Sommerfeld. So who is the scientist? Sommerfeld. So Sommerfeld modifies the which one modifies the Bohr's model. What he is doing? He is doing the he modifies which one? He modifies the Bohr's model. How he modifies the Bohr's model? So Sommerfeld modifies the Bohr model. How he is modifies the Bohr's model? Nothing but by adding the elliptical orbits. How is modified? He is modified. Who is that person? Sommerfeld. So Sommerfeld modifies the which model he will modify he will modify the Bohr's model by adding the which one? By adding the elliptical orbits to the Bohr's model. Adding the which one? Adding the elliptical orbits. So what is the meaning of the elliptical orbits? Nothing but so those are the egg shaped or oval shaped. So oval shaped or egg shaped orbits are called as the elliptical orbits. So what are the elliptical orbits? So those are present in the oval shape or egg shaped it is. So these elliptical orbits are introduced by the which one? Introduced by the Sommerfeld to the which model? To the Bohr's model. So he retains the spherical shape. So he retains the which one? He retains the spherical shape. So where this spherical shape is present? Nothing but in the Bohr's model. So the atom is present in the which shape? In the spherical shape. So in order to retain the spherical shape, so Sommerfeld retains the which one? Retains the spherical shape. So that's why he did not added. He did not added the elliptical orbits. He did not added the elliptical orbits to the first orbit of the Bohr's model. Which orbit it is? That is the first orbit of the Bohr's model. So in order to which one? In order to retain the spherical shape. Where this spherical shape is present? So in the Bohr's model, which is present, the spherical shape is there. So in order to retain that spherical shape, he did not add the electric globes or electrical orbits to the which one? To the first orbit of the Bohr's model. So first orbit of the Bohr's model, he didn't add the elliptical orbits. He is nothing but here Sommerfeld. So he added the elliptical orbits. So he added the elliptical orbits. First elliptical orbit. He added the which one? He added the first elliptical orbits to the second orbit. Second orbit of the Bohr's model. So he added the which one? He added the first elliptic orbits. So he added the first elliptical orbits to the which one? To the second orbit of the Bohr's model, and also he added the second elliptical orbits. Added the second elliptic orbit to the third orbit. Third orbit of the Bohr's model. Third orbit of the Bohr's model. So nothing but, so see here, so this is the Bohr's model of the hydrogen atom. So this is the spherical shape. So in the spherical shape, where is the nucleus is present at the center point? We are already discussed. The nucleus is present, so this is having the positive charge. So this is the spherical shape. So in order to retain the spherical shape, the Sommerfeld did not add the which one did not add the elliptic orbits to the spherical shape. So he added the which one? So here what is that? So here n is equal to 1 and L is equal to 0. So what is the n? Nothing but, so that is the principal quantum number. L is the azimuthal quantum number. So here he added the elliptical orbit. So here if n is equal to 2, so here L is equal to 1. So here we are writing n is equal to 3. So here L is equal to 2. So L is equal to 1 and L is equal to 0. So like this. So these are called as the elliptic orbits. So these are called as the elliptic orbits. So what is the key point here? Nothing but, so in the nucleus, so in the atom at the center which is present, the nucleus is present. So this nucleus plays a main role. So it will play the main role here. So here in the Sommerfeld model of the atom. So Bohr Sommerfeld model of the atom, nothing but, so the periodic motion, which motion? The periodic motion. This type of motion, the periodic motion is influenced by the nucleus attraction force. So which one it is? The periodic motion. So the periodic motion is based upon the which one it is influenced by the nucleus attraction. So this attraction is produced at the one side or one end of the foci. One end of the which one? So one end of the foci. So what is that? The periodic motion, nothing but, so these elliptical orbits, how those are producing? How those are producing? Nothing but, those are producing in the periodic motion. So that periodic motion is influenced by the which one? Nucleus attraction force. So the nuclear attraction force produces at the one end of the foci. So foci, nothing but, so this is the direction here. So this is the foci direction. So this is the generation of the which one? Generation of the elliptic orbits. So you cannot confuse. So listen carefully once again. So this is the which model? It is the Bohr Sommerfeld model of atom. So in the Bohr's model, the Sommerfeld modified the Bohr's model. So that's why it is called as the Bohr Sommerfeld model of atom. How Sommerfeld modified the Bohr's model of the atom? Nothing but by adding the elliptical orbits. By adding the elliptical orbits, Sommerfeld modified the Bohr's model. So what is the elliptical orbits? Nothing but oval shaped or egg shaped orbits are called as the which one? Those are called as the elliptical orbits. So he didn't add the elliptical orbits to the first spherical shape because of to retain the spherical shape. He didn't add the elliptical orbit to the spherical shape, but he added the which one? He added the which one? First orbit of the model to the which one? He added the elliptical orbits to the which one? Second orbit of the Bohr's model. So this is, so he added the elliptical orbits to the second orbit of the Bohr's model, and he added the which one? Second elliptical orbit to the third orbit of the Bohr's model. So these are called as the elliptical orbits. So here what is the key point? Nothing but, so the periodic motion. The periodic motion of the which one? These elliptical orbits based upon the which one? Nucleus attraction force. Where this nucleus attraction force is generated at the one end of the foci here. So this Sommerfeld model is successfully explains the which one? It will successfully explain the fine spectra. It will successfully explain the fine spectra of the hydrogen atom. But so what are the limitations? Nothing but, so it is suitable for only one electron. It is suitable for only one electron containing atoms. If only one electron is possible, so It is explained by the Bohr's model, Bohr's and the Sommerfeld model, but it is not useful for the more than one electron, two or three or the type of electron configuration atoms. It is not possible to explain by the Bohr Sommerfeld of the atom. It is so here one more limitation is there, that is nothing but, so what is nothing but, so the electrons are revolving, so the electrons are revolving in the fixed stationary state, so that is also not explained by the which one, explained by the Bohr Sommerfeld model of the atom. So this is the information about the which one, information about the Bohr Sommerfeld model of the atom. So in the next class, so we are discussing about the quantum numbers. So here also limitations are there. So in order to correct these limitations, what was the next topic? So we have to discuss about the quantum numbers.